So here we considered 2x2 case, 2x2 models, and I have shown several examples of a fully general model. So when you have 4 parameters and they have one-to-one, or also 4 parameters can fully explain the 4 group averages, then your model is fully general. You are capturing every possible aspect in your data from like only in terms of averages. But however, in practice, maybe you have seen something like this. You may be more familiar with this kind of model. It is not wrong. So there is no interaction terms. Then how can we understand this? The main problem here is it is not wrong. There is no multicollinearity. But the problem here is we have only 3 parameters for 4 groups. Then something is missing. Let's interpret what's going on there. So in our 2x2 table, the difference here is, so we can write, it is easy to see what we get from the model. And here, a better way to understand here is we assume delta equals to 0. So the model is this model, So this model, the restricted model is, the widely used model is a variation of this model with delta equals to 0. So then what does that mean? Delta equals to 0 means delta was the difference in differences. The difference in age premiums across genders, or the difference in female premiums across ages. Then either they are equivalent, so we are assuming that the difference is 0. So then have a look at this. The female premium is beta within below 39 years old. So female premium is beta here, and also beta for 40 years old. So the difference is the same in this group and in this group. That is the assumption this model is implicitly making. Or equivalently, you can also see that the age premium is gamma for men. And also, if you look at the difference across these, the age premium is gamma for women. So the age premium is the same for both genders. So that's what we are implicitly assuming in this model. So some authors, some people say it is this model is saturated, and this model is not. This model is not saturated. So anyhow, it is not general, not fully general, because your assumption may be wrong. If your assumption is wrong, if delta is not 0, your model could be wrong. Anyhow, so it is important to understand what your model, when you write down a regression equation, you are making some kind of assumptions. So you have to understand that. Okay, this was a background explanation. Now we are going back to the homework. It is more complicated because there are 2 dummy variables and each has 3 groups. So total, there are 9 groups. There are 9 total groups depending on the type of the car and the country the car was made in. So there are 9 groups. Let's start from number part A. A has S, U, A, G, J. So S is sedan, U is SUV, T is truck, and A is American, G is German, J is Japanese. So we have clear multicollinearity here because you cannot include 3 guys at the same time. So together with the intercept, those intercept plus those 3 variables cause the problem. So you have to drop one of the 4 variables. You may drop the intercept, or you may drop one of those 3. So for example, if you drop J, the last one, then you get this equation. This is a feasible model. You can use this model, and maybe this model is the most common model you see in practice, in reality. But then, as before, your problem is now the number of parameters is smaller than the number of groups you have. Where is the 4 degrees of freedom? 4 degrees of freedom has been disappeared. We are going to study that in this table. So there are 9 groups, 3 by 3, and I filled in the table. Maybe it should be correct. And let's interpret what happened. So first, alpha is easy. Alpha is the average price for Japanese trucks. Japanese trucks is the reference group. So everything from now on will be calculated as the difference from the Japanese truck. And then beta. What's beta? Beta 1 first. Beta 1 is the difference between S and T. So difference between these two, or difference between these two, difference between these two. So the first column and the third column generates a difference of beta 1. And beta 2 is difference between these two. Right? So, so beta 2 is the difference between SUV from truck. That is, so the premiums for sedans and SUVs relative to trucks. And gamma is the difference. Gamma 1 is the difference between first row and the third row. And gamma 2 is the difference between the second and the third rows. So you can interpret them. Gamma 1 is the premium for American cars relative to Japanese cars. By the way, also it's neutral. I'm not saying the premium is positive or negative. And also gamma 2 is the difference of German from Japanese. So that is what your regression model, regression equation gives, and then interpretation. Given these interpretations, you can find the assumptions. The assumptions are the sedan and SUV premiums are the same in all 3 countries. So no matter your car is made in America, Germany, or Japan, the sedan premium is the same, SUV premiums is the same. That is, so this will reduce 2 parameters. So originally, you had to define sedan premium for American, sedan premium for German, sedan premium for Japanese. But by assuming that these 3 are the same, you are reducing 2 number of parameters. And same, the SUV premiums, let me see. So, and the American and German premiums, excuse me, I'm a little bit confused. Oh no. So American and German premiums are also so I was confused. So let me put it this way. So there are 3 sedan premiums and 3 SUV premiums in the fully general model. So sedan premiums for 3 countries and SUV premiums could be different in 3 countries. So there had to be 6 parameters, but you assume that the sedan premiums are the same in 3 countries, so they reduce to 1. And also SUV premiums also is the same in 3 countries, so they reduce to 1. So by doing this, you reduce the number of parameters by 4. So you, instead of 6, you have only 2 parameters. So that's the difference between the number of parameters and the number of groups. You may understand the premiums in the different angle. Like, so we are calculating American premium and German premium. But in a general model, in a more general model, the American premium could be different for trucks, SUVs, and sedans. Then you have to have 3 American premiums, and also there can be 3 German premiums in different types of cars. So there had to be 6, but we assume only 2 parameters can explain all of them. So now then you need to think about whether these assumptions are correct or not. For example, if you believe that, say, American auto companies are better at trucks and say German auto companies are better at sedans, then means American premium must be higher for trucks than the other types. So this assumption breaks down, right? So that's, if you think so you need to understand the assumptions so that if your model is correct or not. You have to think if these assumptions make some sense or not, and if it's too obviously wrong, I don't know the auto market, but it's up to you. It's the researcher's decision whether to make this assumption and simplify the model. And in the simpler model, of course, you can have a more accurate estimator and better, maybe easier to present, and maybe you can have a more powerful interpretation depending on what you get and what you want to look at. So think about these assumptions. Okay, so the next question, B. In this example, there is no intercept, but still there is a multicollinearity, because SUT equals S plus U plus T equals A plus G plus J. So also it is easy to see that the multicollinearity problem exists. And now I'm not going to show you what's the underlying assumptions, and so you need to drop one of them, any of the 6 variables, then it will work. But then you need to think about what is the assumptions you are using. The answer is the same as before, and also think about what is the interpretation of those parameters. So, and think about the assumptions, and that will be the same as before. You will have 5 parameters for 9 groups. So in the end, you will see the same assumptions as before. Part C. Now we have interaction terms. There is a multicollinearity coming from these 3. So these 3 interaction terms always sum to this single dummy variable. So these 4 variables together cause the trouble. So you have to drop one of them. And suppose that we drop the last one, and you have this much equation, but it works. Now you do not have any multicollinearity, I believe, but you only have 7 parameters. There must be 2 assumptions, some assumptions that reduce the number of parameters by 2. What's that? It's think about that. It is your practice. It will be an interesting thing to study. And the final one, most complicated one, there are 11 parameters. So it is easy to see that there is some problem. You have only 9 groups which cannot support 11 parameters. So at least 2 parameters must be removed, at least 2. And the multicollinearity is coming from this and this, right? And it's easy. And then delete one of these 4 and another one of these 4. So the answer is simple. It's up to you what you delete. And you have 9 parameters then. and it should be one-to-one. So 9 parameters should be fully generally explain the 9 groups. So you are going to get the fully general model if you use this one. And then finally, okay, this is how you handle dummy variables and interaction terms, and so the simplest possible examples of multicollinearity. Here I will test you. Think about this equation. Is it multicollinear or not? And second, even more complicated, does it have a multicollinearity or not? Interpret those parameters. So very tricky and really interesting if you go deeper into the model. Okay, I hope you enjoyed homework, and sorry for the errors. It is impossible to have error-free homework okay, thank you for your answers, and I'm going to give you the feedbacks later. And if you have questions, feel free to contact me, and feel free to stop by the office hours. So far, there was only one student who came, 2 students who came to my office hours, and I'm waiting for you. Sometimes I forget to be in the Zoom meeting, so please let me know. Remind me that you are coming to the office hours so that I can remember I need to access the Zoom meeting. Okay, see you later. See you next week.